So let's get started. We already had a brief look at a schedule, and I think we'll see a lot of great talks today. But what I want to kick off the day with is to give you a bit more of like a broader overview of like why we're doing what we're doing. But first of all, thank you so much for coming all out here. We have some people from coming all over the world, San Francisco, and from other places of the world. So thank you so much for coming today. And I think the most important thing today is really like we have so many interesting different people here that are sharing their knowledge otherwise. So please feel free, make sure to connect, talk to each other, learn from each other, share your knowledge. I think this is what this day is all about. So, and we have plenty of opportunities for that today. So we'll have a lot of breaks throughout the day, but we'll also have the barbecue at the end of the day. So please make sure to connect with everybody and have a great day. So, and luckily we also have a lot of good weather today. Berlin is quite hot, but it's cool inside. So I guess everything is set up nicely. So who's a developer? Right, that's what I thought. I think this is what brings all of us here. And because all of us, we want to build applications and we want to have a good time building applications. And I think it's a really great time to be a developer. When I got started, I think like 14 years ago with development, I actually got started in web design. So what I spend my time with is doing designs in Photoshop, slicing them up, exporting them for the web, and like then arranging everything in table layouts. That was like before like divs were really a thing, etc. So that was really like the early beginnings of the web. JavaScript wasn't also really a thing. And today the design process alone, like how we can build visual applications, have improved so much. We have tools like Sketch, we have tools like Figma. A big step forward. And the same is true for the web. Back then, JavaScript was barely a thing. When you've asked people on Stack Overflow, they haven't really, like, nah, this JavaScript is not really a thing. Then MooTools came along, jQuery came along, and then with big word, Backbone, Angular, now we have React, we have Vue, and building web applications is possible at a scale that wasn't really imaginable 10 years ago. So, but also on the back end, things have improved so much and make it easier for us as developers to build applications. So back then, it was a real hassle to get a web application up and running. Get servers, physical servers, or we had to deal with like PHP hosts, and our website would be down if a bit of traffic would hit them. And today we have like amazing platforms like Netlify, Site. We can use cloud, AWS, and scaling applications is incredibly easy now in the age of serverless, where we can just deploy things on Lambda. But as all of this has changed and improved, I think one area hasn't really improved. I would even argue back then it was easier to build applications. Back in the days where Rails was learn, every application was built with Rails or Django. I think the area around data workflows was a lot smoother, a lot more integrated. And today, as the world has moved on to different programming languages, JavaScript, we're using TypeScript, we're using Go, there the ecosystem hasn't really caught up. Everything is kind of like a fragmented point solution that everybody's using, but it's not a really great great experience using them. And we waste a lot of time putting up with these different tools. So, and this is really why we are building what we're building at Prisma. Our goal at Prisma is to empower you as developers to build data-intensive applications. And the way how we do that is by talking to a lot of people like you, see what are your pain points, how do you want to build that are data. But what we are also doing is talking to a lot of larger companies at a scale of Twitter, etc. Like, what have these companies, they same pain, they have the same problems. How have these companies solved these problems internally in their company? So, and they've been investing tens of millions of dollars. That is an alarm. They've been investing tens of millions of dollars to building internal developer platforms. And these developer platforms make it incredibly easy for build applications at scale.
All right, perfect. I hope all of you could still follow what I've been talking about before. I hope my voice was loud enough before. So to recap, we've been spending the last 3 years basically talking to people like you and talking to
large companies, some of the leading companies when it comes to building applications at scale, and they need to do so in a way that their developers are productive. And the way how they do that is by investing a lot in internal developer platforms. And our goal at Prisma is basically to bring these two approaches together. So we've been spending a lot of time with these companies, seeing what have they built internally, and we want to make these tools accessible to everybody, and bring these scalable solutions to everybody. So the way how we think about this is like as a scalable solution, a solution that works at scale, but also is super easy to adopt and lightweight that you would use it in your own side project. And I think React, GraphQL, serverless, they are all great examples for this. You would use them at your side project because it just gets out of your way, but it scales with the scale of your application, with the scale of your engineering organization. So we've been focusing, there's a lot that these platforms have to solve, but some of the workflows that we see the most critical is really data access and schema migrations. This is what we're focusing on right now and building tools. And Peter has already mentioned it. Yesterday was a really, really big day for us as we announced the first preview of Prisma 2, where we've announced Photon and Lift. So at that point, I also want to give a huge round of applause and a big thank you for the team for the incredible work to make this happen. There was a huge effort, so thanks a lot. So for those of you who haven't read it, Photon is basically an evolution of what Prisma Client was so far. It's an auto-generated database client that comes with a highly optimized query engine embedded and is compatible with MySQL, Postgres, SQLite, and over time will add support for more and more databases. The counterpart to that for schema migrations is Lift. So it's a way how you can declaratively model your database schema, and you automatically get migrations generated that you can put into version control and apply in CI/CD. So we're building all of these tools as standalone tools, as standalone workflows. But what's really been at the heart of how we're thinking about building things is really also in combination of being used with frameworks. I think this is what made Rails great. This is what makes Django great, by integrating all of these workflows. And in today's world, there are a lot of different frameworks. There are a lot of different approaches. And we want to make sure that the tools that we're building work nicely with all of these frameworks. So we're spending a lot of time with the people behind these different frameworks and are planning to implement deep integrations with these frameworks. So watch out for some nice announcements over the coming months where Prisma, Photon, and Lift comes to these frameworks. But throughout this keynote, I want to talk specifically about data access. This is, I think, one of the hardest problems when it comes to database workflows. And specifically, I don't mean like data access throughout like a large, complex architecture. This is a talk for the next few years. But what I want to talk about today is more like on a micro level. How do you build a backend applications, a microservice? How does that service talk to a database? And there are a lot of things to consider. Let's say you're starting out a new project. One of the key questions you need to ask yourself, which database are we using? And this is a really difficult question where the honest answer is it depends. It depends on your data access patterns, depends on where you want to host it, depends on like what your company is familiar with. Or if you have an existing project, then you don't really have a choice. Another important consideration is which programming language are you using? Again, for an existing project, you don't really have a choice. But for a new project, you need to make this decision very, very carefully. And this has huge implications on what sort of power you have in your program language to access data. And the question that I would like to talk most about now is, which level of abstraction should you use to access data? I've been building a lot of applications over the last 10 years and tried out a lot of different approaches. And especially in JavaScript and Go, I've got very burned by all of these different tools. So I kind of like got back and said, okay, all of this like doesn't work. I'll go back to building raw SQL. I'll just talk to Postgres directly. And throughout the months of building something, it's a pretty simple app. I found myself writing queries like these. And so this is actually just a small part of the query. The query is actually pretty long. This is, for a simple endpoint, a query that spans like 100 lines of code. And while I was smart enough to write that initially, and in the moment where I wrote this query, I knew exactly what was going on, then my application had to change. I wanted to ship features, iterate, etc. And stuff would break constantly. So this was really like the biggest bottleneck for me to move quickly, since it was unmaintainable and I couldn't move quickly. So since I was building full stack applications, I was exposed to a lot of different technologies, a lot of different approaches. And where I saw a similar transition, where things bogged me down, where it was like using jQuery before, etc., and then React was really like this big moment where I could focus on building my application, not on mutating DOM. I really thought about, okay, what is the right abstraction here? And an abstraction brings a few things to the table. It brings a better paradigm, it separates the concerns, and also gives you the benefit of portability. And for React, that means with React, you got components. You can declaratively describe your components. You get isolated state in these components. And you can focus on building your application. A smart team at Facebook is focused on building the virtual DOM and like how things are, how your application is actually rendered. This is a super big deal. You should be focused on building applications. You should not be focused on thinking about how you re-render the DOM constantly. And it's the exact same thing for data. You should be thinking about like what sort of data you need. You shouldn't be worried about like, oh, how does this database exactly work efficiently again? And so this is what we want to provide with Prisma. We want to give you a declarative higher level API with a query engine that we are focused on, that we spend a lot of time and engineering effort making sure that it generates optimized queries. And a benefit that you get all of this is that with React, you can use it on the web, on mobile. And for Prisma, we are aiming to bring the power of Prisma to any programming language and was compatible with any database. Obviously, this is a far goal. We're starting with JavaScript and TypeScript and Go. And right now, I have already support for Postgres, MySQL. MongoDB will be reintroduced in Prisma 2 shortly, and we're working on more connectors. So let's take a look at like different database abstractions that there are today. And I guess the most common database abstraction that all of you have heard about is an ORM. And ORMs, by the definition of Martin Fowler, there are really two kinds of ORMs. The most common one is active record, which has also been popularized by Hibernate or by active record as part of Rails. In JavaScript, there's Sequelize, for example. There's also a different approach called the data mapper. Massive.js is, for example, a great implementation of that. If you're using a document database like Mongo, you might be familiar with Mongoose. And these tools together form the category of an object mapper. The idea is basically to map a table, a collection, to a class in your application. The other approach are query builders. For example, a SQL query builder like Knex. This is the idea of bringing a lightweight wrapper of mapping SQL into your programming language. So these are fundamentally the two different approaches. But I think the most common one, the most commonly used one, is an ORM. So who of you uses an ORM or has used an ORM? Keep your hands up. Who of you has had problems with an ORM? All right, that's what I thought. So this is actually a very common situation, and this is a well-understood problem. There is a lot of literature about this, like some of them like more than a decade old. For example, the most popular one is probably the article, The Vietnam of Computer Science, that depicts some of these problems. And I think the most important thing to understand here is that ORMs are really a result out of the idea that everything is, that there was the creation in a time where object-oriented programming was absolutely the default, and you wanted to bring databases into the world of object-oriented programming. And the result of that is that you basically try to hide your database behind classes. And the way how you think about object-oriented programming is you just like access object, everything is kind of in memory, and so you're hiding the reality, really. And this is a misleading, leaky abstraction, really, because like database access is not free, and you try to apply a lot of your object-oriented best practices, like inheritance, etc., to this model, and this is inherently just like a bad match. So this is called the object-relational impedance mismatch. If you're interested in learning more about that, I highly recommend reading these articles. But the solution to this is fundamentally a different approach. And the idea is basically to explicitly and declaratively say what sort of data you want to fetch. And this has been an emerging best practice based on the learnings over almost the last 2 decades. And the idea here is basically to say explicitly when and what sort of data you want. And you do it in a declarative way. That means like you don't need to specify how it should be, how you should get it, but just what. And this enables this typed, nicely high-level API that enables a whole bunch of tooling and enables you to build tools that give you predictable performance. So I think this is the most important thing to understand about ORMs and the inherent problems with them. But the current state of data tooling also brings a whole bunch of other issues. And I think these other issues are also at the core of what we're trying to solve with the tools that we're building with Photon and Lift, etc. I think one of the most common problems is that these data tools are super error-prone in their current implementation. And that's not a surprise. All of these tools have really been created by hobbyists that just have so much time to invest into them to don't really make them proper. A good example for that is we've been building web applications. We've been building web applications before React, but we didn't really have the time to build our own React to make our life easier. We just use what's available. And that leads to brittle and error-prone code. And the core problem that is here, the case, is that you're trying to fundamentally map from one thing to another. You're trying to map from your database schema into your application. And this mapping is you're writing that by hand, and that's brittle. Another problem is that the queries that you're writing, you don't have like any guarantees that they're correct. It's really hard to maintain and to refactor, as we've seen by this big query that I showed before. And the real solution for that is pick a clear source of truth for that mapping. For example, your database schema, introspect the database schema, and generate a database client for that. That's exactly what Photon is doing. And if you're using a typed language, then you can use the type safety of that language to help you correct these errors. Another common problem is that these tools try to give you a higher level abstraction, but don't go all the way. So they still expose a lot of the low-level details. So you still need to think about things like joining tables, etc. And the solution that we thought about here is like looking at all of the common use cases that you have. For example, you want to expose relations. You want to think about what are common write scenarios that you have that you want to do in a transactional way. You think about upserts, badging, pagination. All of these are first-level primitives that we provide with Prisma. And I think one of the things that give you the most productivity in your daily life as a developer is by using the features of a language that you use. And I think this is the entire idea of providing an abstraction from your database into your programming language. SQL is a nice nicely portable abstraction, but it doesn't really fit nicely into your programming language. You want to think about building applications in JavaScript or in Go. And I think this is the problem that we need to solve with proper tooling. And the idea of Photon is using all of the great benefits that a programming language give you, for example, type safety. And I think this is, maybe you've already tried it out, this is one of the things that makes me so excited about Photon, that we get to use all of the great benefits that modern programming languages give you to access data. So we've been actually been very cutting edge by using some of the latest features of TypeScript. Some of them actually just got merged into the latest version of TypeScript 2 weeks ago that we are already using. And that allows you to write very concise code that give you a lot of guarantees. So that means you get nice auto-completion, nice error messages. As you iterate on your database schema, your editor will tell you what will break before it breaks in production. And the last thing that where we are well suited as a company to tackle this problem is that most tools, as said, are built by hobbyists that just try to solve their own problem, but they don't really have like a real commitment to solve these problems as a category. And all of these tools, this is what we're using in production. This is what large companies, enterprise companies use in production. This is what governments run on, etc. They're using tools that have built by hobbyists that no longer are interested in maintaining these tools. Severe issues go unfixed for years or for indefinitely, and developers have to put up with it. And this is the problem that we're trying to solve with Prisma. We're a well-funded venture-backed company where our strategy is to build open source tools, and this is where we're building product teams, engineering teams, etc. So at that point also, if you're interested in new opportunities, please talk to us. We're hiring right now as well. So this was a brief overview over some of the problems that we're trying to solve in regards to data access. And hopefully the biggest takeaway there is that I think there's a huge opportunity to provide a better developer experience for these tools to make you more productive as a developer, but also doing so with an inherently more scalable abstraction where you think about data access in an explicit and declarative way. And the other tool that I haven't yet talked much about, but where we'll see a couple of demos throughout the day, is Lift, that enables you to model your data in a declarative way and automatically get schema migrations. So this is what we're doing at Prisma. We're building tools for database workflows. I'm really looking forward to the rest of the talks today, and we'll now hand it over to Matt, where you'll see all of these tools in action and hear Matt's personal story to that. So thank you so much, and looking forward to talking to all of you later today. Thank you.